Okay.
So, I'm going to just show you real quick at that what I'm talking about as far as identifying the spiders. So at the end here, you have this key, and you can actually identify the spiders to family, even though some of them have to be further identified anyway. That's not necessary. That is there. What I usually have done in the past, like I will call, you have to start the first site, call this spider A. So here's one spider A, two spider A, and then here's spider B, because this is a different one. You just have to remember that this spider A needs to be the same as this spider A in site 2. So you need to make sure that they're consistent when you're identifying them. Okay, but here I've identified them by family and then by species within the family. Okay, so for this family, there's 10 different species. Identify them in 1 through 10, and then with these other families. Okay, so looked at site 1, and for each of these individual spider species, we counted how many of each of them were present in site 1. And so for site 1, we had 5 of each of these, 5 individuals of each of these species, as well as these species here belonging to these families. Okay, so this is Salticidae 1 and 2, and there were 5 of each of those. And so if you add all of those up, you'll see you should have a total of 50 spiders. And for this example, there are 50 spiders across the board, across each site. Okay, so you can go through and add how many species were present in the site. And so just physically, just going through and adding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 species there. And so there are, if you're good with Excel and you know how to use some of the functions, you can have them count for you. If not, you can just go through and count them yourself, but this is very handy. And if you don't know how to do, there's lots of tutorials online, but it's this function button here. And there are many functions that you can explore. Let's see, if I go into an empty cell, look up functions, you can even type what you want to count, and it will give you all the count functions. So this is very handy to have, but in this case, it's simple enough that you can just count. Okay, so you'll need to do that for each site, again, with consistency across the families and species, but the names don't matter. And keep in mind too that if you misidentify something, that's fine, because that's not the point. The point is not how well you're counting these spiders. The point is really this stuff down here and how you're calculating it. So don't stress out too much if you can't tell exactly what spider belongs to this family or that family. Just pick one, and then it's the process that's really important here. Okay, so any questions about this part? Just the tallying of the species. Okay, yeah, thank you. We got a question about richness. And again, you can go back to the slides, but richness is just a count of the number of species present without any regard for how those species are distributed. So in this case, we have 10 different unique species here. You need to do all the species. So you're going to use all the sites and all the species for all of this, for this entire assignment, except for the collector's curve, which you only have to do for site 1. Okay. I want to make sure, Gabriel, I'll get to your question in 1 second. Michelle, I want to make sure that I answer your question about richness. It's a measure of diversity, but it's just the number of species that are represented. Okay, great. Gabriel, you had a question?
Yes, I was wondering, is this tally that we're looking at, is that just one group? Or is that all the groups?
This is all the groups. So site here across the top. So this is site 1, which corresponds to
I didn't see that.
these spiders. It's a good question though, because it's confusing. It's not confusing or hard once you understand, but it is a little hard to grasp. So this column here will be for site 2, which is further down in the assignment, and hard to see on your screen, easier to see on the actual PDF that I have. So hopefully once you get it, looking at it on your computer directly, you'll be able to see better. But does that make sense to everybody? You'll have to go through and count all those spiders from each of the 5 sites.
Now, do you want us to do it exactly how you did it, or sort of do our own way?
The form needs to look, well, you know, you can do it however you would like it, as long as you get these same results. You need to have the total number of species that are present, and you need to have each site, the population needs to be broken down like this. But if you have a different way that you would like to organize it, that's fine. I found that this was easier because of future steps, which we'll talk about in just a minute. So, all right. So, are there any other questions on the counting part for right now? All right. So let's move on to the collector's curve. And again, we talked about how that is a measure of how, your sample is representative of the population that you're sampling. And that is because when you just have a few individuals and you continue to sample, you would expect to get more examples of different or unique species. And as you get sample more and more, you're just going to start seeing individuals of species that you've already noted. So you'll see less and less unique species. And so once that happens, it's safe to conclude that your sample is representative. And so you know to stop sampling. You don't have to use any more resources towards sampling and identifying. Okay, so in order to do that, and so that's the part that you only have to do for site 1, is the collector's curve. I would format it like this. So you're looking at, so you want to plot each specimen that you have at each site. All right, so each site is going to have 50 specimens because this is a theoretical example. Okay, so when you get your first individual, that's going to be, that first individual is going to be a unique species. It's the first species that you have present. So you would plot that as one species here on the y-axis and the number of individual spiders along the x-axis. So that's this point right here. So then if you're looking at site 1 as an example, okay, so this second spider here is the same spider as the first, but you have 2 spiders now. So on the x-axis, you have to plot your total number of spiders. So your cumulative sample size is 2, but you still only have 1 species here. Okay, so it's a straight line. Then if you go to the third spider, so here's spider 3, but this is a new species. So now you have 3 spiders, but they represent 2 different species. So in the collector's curve, that's this spider here. So your third spider, you have 3 spiders all together, but you have 2 species being represented. You do one more. So this next spider again is the same. So you have 4 spiders, but 2 species, again represented here. So here's 4 spiders, 1, 2, 3, 4, but 2 species. And then so on and so forth until you get all the way to 50. So then you can see that this kind of starts, it increases until you finally get to a point to where within this population, you're no longer finding new species. They're all represented already earlier in the graph. And so when you get to this plateau, then that's your indicator that your sample is representative and you can stop sampling. Does this make sense to everybody? Okay, good. I'm glad to hear that. Okay, excellent. Okay, so let's go back to your packet for a moment. Okay, so the next step then, that's a good question, data analysis to produce the graph. You have to go to insert and then do what I have, a scatter plot. Yeah, I did this line with markers. All right, and then let's see, I was trying to see the actual, select the options that I get. So if I'm going to do this somewhere else, then so you can see over here, these are the highlighted columns that I have. So this is the number of individual spiders. So that's the x-axis, and then the number of species here. Now, I will say that do not require that this be done in Excel, even though it's very helpful if you can learn how to do this. I also included graph paper that you get if you want to do it that way. I will make this graph real quick just to show you. So you just have any empty spot there. Say, do a scatter plot. Select data. Okay, so select data is up here. So you can select your range of data to start with. So that's all your data. Okay, and then I want, see if you want to add, oops. Okay, so I want to edit my series. All right, so on my X values, I want the number of individual spiders. So that's this row. All right. On my Y value, this is the number of species. So that's this row. Okay. And then, so that's this series here. So you can just click OK. And then you can see that I've created a similar graph, and then go through and format the chart, get rid of lines and stuff like that. But none of that is really the important thing here. But if you can play around with this and get this chart, that's a really good skill to have, and would be beneficial to you in the long run, I think. But feel free to use the graph paper if you prefer to go that route. Okay, so I wanted to go back and look at using okay, so let's look at the Simpson reciprocal index. Now, this is different from richness because richness is just a count of the species without any regard for the distribution. This index will look at the distribution by considering the proportion of each species' contribution to the population. All right, so So the equation here is the proportions of each individual of species squared, taking the sum of all those square proportions and then taking the reciprocal of that. And then you can have up to a maximum of the total number of species that are present. And that would mean a perfectly distributed, all even number of individuals for each species. And then the smaller the number is, then the lower the diversity is. And then that would indicate that the diversity is low and most individuals are one or a couple of species. And so it outlines that here. The maximum value is the number of species in the sample, which occurs when all species contain an equal number of individuals. All right, so that's termed of, so it's basically a reflection of how balanced the communities are with individuals distributed across the species. You can also call it evenness. Okay, so like I said, two communities can have identical number of species and therefore species richness, but can be very different in their diversity measure if the community is skewed towards just a few species. Okay, so let's look at this in our table, this equation then, this process of calculating this. So we've already calculated richness here, and we've gotten an idea a little bit about what these sites look like. All right, so you have the most species in site 1, the least species in site 5. But we don't know anything about how similar they are, and we don't know anything about, it would be very difficult to compare what the diversity looks like. This is just one simple measure. So the next step then is to look at the site proportions, which the proportion is going to be the number of individuals, divided by the total number of specimens. So you want to calculate this for each species. Okay, so you're going to calculate that for each species that you have present. You want to know what proportion of my population was Aranidae 7, which population was Aranidae 8, what proportion of my population was this species, and so on and so forth, until you know for each species what proportion of the population they are. Okay, so for site 1, which we were just looking at, there were 5 individuals of this species, and there were 50 total, and so you have a proportion of 0.1, right? Because I have an equation up here to refer back to my tally, but you don't have to do that. You can do it manually if you need to. But basically, you're just looking at, 5 divided by 50, 0.1. 5 divided by 50, 0.1. So you get those values for each of these. Because for that site, there was 5 of each of these species. You have a proportion of 0.1 for each of those. You'll need to do that for each species in each site. Does that make sense, or questions right now? Okay, very good. Okay, so the next step in this process, then, all right, so you have to square the equation calls to square all those proportions and then add them all together. All right, so that's the next step here. So these are, now I'm squaring each of those proportions that we saw on the previous table. So these are the tables that are referred to in the rubric. This one isn't mentioned specifically, but you're going to have it in order to calculate the others. So the site proportions, and then so squaring each of those pursuant to the equation, and then adding them up. That's the sum part of the equation. So the sum of all the squared, so the Simpson's index, D, equals the sum of all those squared proportions. Okay, so you square all those, sum them up, which can easily be done with this auto sum function over here. You just highlight the values that you want included in your sum, and it will automatically calculate that for you. Okay, but remember, this is the Simpsons index, and we're looking at the reciprocal index. And so the final step that you need to do here is to take your D value and divide it into 1. And so you can see that perfect example here. There's 10 species present in site 1, which we saw from the richness. And each of those 10 species were represented by 5 individuals. So that is that ideal perfect scenario where the individuals are perfectly distributed across all of the species that are present. And so therefore you get a reciprocal index with the same value as the number of species. Okay, so we do this now with each of the sites. And then you have to be sure to then take the reciprocal. And so, like I said, this is a measure of species diversity and includes the richness and the distribution. And so the greater the value, and how to interpret this is the greater the value, the greater diversity, and maximum number is the number of species in the sample. Was there a question about this part?
Yes. Can you tell me what the just the sum or whatever that little just could you just click on one of the numbers in like C12 or whatever, or which one did you click on? It was like equals sum and then a parenthesis, and then I just want to see what that looks like.
Oh, here.
Oh, okay.
Is this what you're looking at? So
Yeah.
This is where I'm trying to add these up. And so I use this sum function here in this cell and told it to add up all of these.
So we just click that function and then it'll like tell us what to do after that?
Yep. Let me see. Let me just put some random numbers in here. So you just put it you want a blank cell, and then click on the auto sum. It'll kind of make its best guess at what it thinks you want to add up. If that's not correct, you can just highlight whatever you want, change it however you want, hit enter, and it will add those up for you. If you click on it, double click on it, it will highlight what it's including in that value.
Okay. All right. Thank you.
Mm-hmm. Okay, any other questions about this portion? Okay. All right, so let's talk about the last calculation here, the coefficient of community similarity. This is the matrix of those comparisons that we were talking about in the assignment packet. That's this. So this CCJ is community similarity, and then this is the equation. C stands for the number of species that have in common, and then you divide it by the total number of species that are present in the two communities. So, for example, if one site contains only 2 species, and the other site contains 2 species, and one of them is the same, so they have 1 species in common, but the total number of species between them is 3. Okay, it's not 4 because they share 1, so there's only 3 total, but they share 1. So the community similarity index in this case will be 33%. This index ranges from 0 to 1. So if there's no species in common, that calculation will equal 0. And if all the species are in common, then that will equal 1. But again, there's no inclusion of abundance in this metric, distribution, abundance or distribution, however you want to think of it. So again, this is a complementary metric that you would use to rank your sites. Okay, so we've calculated that for each of these. I made this matrix so since you can only compare 2 sites at a time. So if you do a matrix like this, you have to X out the comparisons of the sites to themselves. But then you would do a comparison between site 1 and 2, 1 and 3, 1 and 4, 1 and 5, and so on and so forth. Go down the rows, you'll end up with this matrix. And then what you can do is go by each site and get an average community similarity value here. And then you can use that to make some general statements or some general comparisons. So you can see straight away that site 4 doesn't have any species in common with any of the other sites. So that's very unique. So you might want to go back and look at site 4 and see, are there any endemic species there? What does the distribution look like? Why is it so different? Look at site 4, see it's got a fairly high Simpsons index. So that might, along with the information that it's not similar to any other site, unique, that might be a compelling reason to focus on this site for conservation. So remember this ranges from 0 to 1. So the values that are closer to 1 have more species in common. So I'm looking at site 2 seems to have a fairly high similarity average. If you look back, it's got this range, a pretty wide range, especially compared to site 1, got a lower similarity. And so this is just an additional piece of information that you can use to consider conservation value and conservation decisions or management decisions. Okay, does this make sense? Questions about this?
What is a matrix?
Oh, I'm just calling this grid of comparisons a matrix.
And when you said you were this shows the Simpson, what does that mean? Or I forget what you had exactly said, but it was something Simpson. Okay. I'm like, okay, well, what does that mean?
Well, when I was talking about site 4 here, I mentioned the Simpsons index, the reciprocal Simpsons index, because this site is very unique. It's not similar. It has 0 species in common with any of the other ones. So I was suggesting that may have increased its conservation value because it's unique. And so I had gone back and looked at the reciprocal index, Simpsons index for site 4, to see what the species richness was, and to just consider this additional piece of information when I'm evaluating.
Okay.
Does that make if anybody else heard anything different, please speak up. I think that was my reference back to the Simpsons, just to consider this other piece of information, because that site is unique. And you could have had the case where that site had very low richness, right? Where there were only a few species present, but of many individuals, and that's why it was not similar to the other populations. But when I went back and looked, it has a pretty decent diversity index, and so that one may be worth looking at because there's not other similar areas out there.
That makes sense. Yeah, I'm recording this whole thing, so I'll go back and
Okay.
watch it again.
Okay.
But thank you.
Okay, so I see a question about the formula.